Hello everyone, and welcome to today's presentation. I'm excited to have you here. Today, we'll be exploring control structures in programming. The title of our talk is Control Structures in Programming. We'll cover what they are, why they're important, and how they help us create more complex and effective code. So let's get started and dive into the fundamentals of control structures. Let's talk about control structures, starting with the statement's relationship. In programming, control structures determine how the code is executed, and one of the most fundamental is the execution order. This is where the sequence control structure comes into play. Essentially, it executes code in a specific, predictable order. Think of it like following a recipe. Each step follows the previous one carefully. This makes sequence the simplest form of control structure because it's straightforward. Statements are executed one after the other without any surprises. The key point here is that the order of execution is defined and maintained, which helps us understand how programs run from start to finish. Connecting this to the overall theme of programming, understanding sequence is crucial because it forms the foundation for more complex control structures. When you grasp how code runs in order, you can start to explore conditions, loops, and other structures that add more flexibility and power to your programs. Now let's take a look at how code can execute different paths based on certain criteria. This is where decision-making really comes into play. In programming, we use conditions, like if and else statements, to make choices. These conditions help the program decide what to do next, depending on the data or situation. Think of it as giving the program a set of questions to answer. If the answer is yes, it follows one path. If no, it takes a different route. This process of choosing between options is what we call conditional logic. It's essential because it allows our programs to be flexible and responsive to different scenarios. On this slide, you see the numbers 1, 2, and 3, which represent different paths the program can take. The key idea here is that decision-making in code enables us to control the flow of the program, making it smarter and more adaptable. So, in summary, decision-making through selection in programming is about making choices based on conditions, which ultimately makes our code more dynamic and capable of handling complex tasks. Let's talk about how using efficient coding practices can really help us out. One major benefit is that it reduces both code redundancy and errors. When we write less repetitive code, there's less chance of making mistakes, and it also makes our programs easier to maintain and update. Now, a lot of the common ways we repeat tasks in programming involve loops, like for and while loops. These are essential tools that allow us to perform the same set of instructions multiple times without rewriting the code each time. This idea of task repetition is fundamental. It's about automating repeated actions so we don't waste time and effort. When we utilize iteration properly, it streamlines our code and helps keep it clean and efficient. So, by focusing on code efficiency through iteration, we're not only making our programs more reliable, but also more aligned with best practices in software development. This all ties back to our goal of creating better, more maintainable code in the most effective way. Used in all programming languages, the concept we're discussing today is truly universal. It's a fundamental aspect that applies no matter what language you're working with. Moving to the next point, this is also critical for program correctness. Ensuring that your program works as intended is the foundation of good programming practice. If the logic doesn't flow properly, the whole program can behave unpredictably. That's where logical flow comes into play. It ensures that the execution of your code follows a logical, coherent sequence. And at the core of all this is the importance of sequence itself. Getting the order right is essential for the program to function correctly and efficiently. So, remember, understanding and managing sequence isn't just a technical detail. It's central to writing reliable, effective code. Let's talk about how selection enhances our decision-making process. First, it facilitates adaptable and flexible choices, allowing us to respond differently depending on the situation. Then, we have the concept of dynamic decision-making, which helps us make more nuanced decisions by considering various conditions. When conditions aren't exactly what we expect, providing alternatives becomes crucial, and that's where the else statement comes into play. It gives us a way to handle situations where our initial conditions aren't met, ensuring our program can still respond appropriately. Finally, at the core of this process is the if statement. It checks specific conditions to determine the course of action, acting as the gatekeeper for decision-making. By using selection in decision-making, we make our programs more adaptable, flexible, and capable of handling a variety of scenarios. This is a key part of writing smarter, more responsive code. Now, let's talk about processing collections. This is really useful when you want to continue executing some code based on a specific condition. For example, maybe you're going through a list and want to keep processing items until a certain condition is no longer true. That's where while loops come into play. They allow you to repeat a block of code as long as a condition remains true. On the other hand, if you know exactly how many times you need to run a piece of code, for loops are your best friend. They help you iterate a set number of times efficiently and cleanly. Understanding loops overall is crucial because they're fundamental in automating repetitive tasks. They help make your code more concise and readable, especially when working with collections like lists or arrays. So, whether you're continuing based on a condition or iterating a specific number of times, mastering these looping techniques is key to effective programming. Let's take a closer look at slide 8. Here, we see the progression of topics, starting with examples of sequences. This is fundamental because understanding sequences helps us grasp how data flows in programming. Next, we move to simple arithmetic calculations, which are the building blocks for many algorithms and operations. Finally, we look at code snippets in order, illustrating how these concepts come together in actual code. The key point here is that mastering sequences and basic calculations is essential before diving into program initialization steps, which are the foundation for executing any program smoothly. By connecting these ideas, we're building a solid understanding of how to structure and understand code effectively. This progression, from sequences to calculations to code snippets, mirrors the logical flow of developing and understanding programming logic. All right, let's dive into some strategies for processing and validating user inputs. When we're dealing with user input handling scenarios, it's important to consider different possible cases and how to respond to each. One of the most common techniques is utilizing if and else statements, and sometimes even nesting them within each other to handle more intricate scenarios. Nested conditions allow us to build complex logical flows, which are essential when our validation depends on multiple factors. Think of them as a way to drill down into specific situations based on previous conditions, making our programs smarter and more adaptable. At the core, these are fundamental control structures in programming that help us direct the flow based on different conditions. Basic if and else statements are simple but powerful. They let us execute certain code only when specific conditions are met. And when we look at examples of selection, we see how these structures enable us to choose different paths in our code depending on user input. This flexibility is key to creating robust applications that can handle a variety of user behaviors efficiently. Remember, mastering these logic structures is crucial for ensuring our programs are both functional and user-friendly. Let's talk about how tasks can be executed continuously until a specific condition is met. This concept is fundamental in programming because it allows us to automate repetitive actions efficiently. Now, when we want to repeat tasks, using loops is the most effective way to do this. For example, loops help us sum values quickly without writing extra code for each step. Imagine summing a series of numbers. Loops make that process seamless and straightforward. Similarly, loops are great for counting things, like counting how many times a particular event occurs or how many iterations a process takes. This is especially useful when we're analyzing data or controlling program flow. Throughout this presentation, we've seen various examples of iteration, which is essentially repeating a process multiple times. Whether we're summing numbers, counting loops, or performing other repetitive tasks, Understanding how to use loops effectively is key to writing efficient, clean code. Remember, the power of iteration lies in its ability to simplify complex tasks through repetition, making your programs more dynamic and adaptable. All right, let's dive into slide 11. First, we see that looping over code is enabled through iteration. This is a fundamental concept that allows us to repeat certain actions efficiently, which is essential in programming. Next, we have used for decision-making in code, which is all about making choices based on conditions. This is what we call selection, and it's how programs decide what to do next depending on different scenarios. Then, we come to sequence, which is simply the basic order in which instructions are executed. Recognizing these control structures, iteration, selection, and sequence, is crucial because they form the backbone of how we control the flow of a program. To summarize, understanding these key concepts helps us create more dynamic and efficient code, tying everything together in the broader theme of mastering programming logic. Let's take a closer look at the importance of algorithms in programming. As you can see, understanding algorithms is key because they form the backbone of problem-solving in coding. They help us efficiently process data and create effective solutions. Moving on, the slide highlights how games are a practical application of programming. Games are not just entertainment. They also serve as excellent platforms to learn about programming concepts like logic, design, and user interaction. Lastly, understanding these practical applications is vital because they connect directly to the overall theme of our presentation. How foundational programming concepts, like algorithms, are essential across various domains. Whether it's gaming, data processing, or developing advanced software, the principles we learn here are universally applicable and crucial for success in the tech world. Let's wrap up with the key takeaway here. Practice with all programming structures really does improve outcomes. When we regularly work with different types of structures, we get better at writing efficient and effective code. Remember, improved outcomes come from understanding and applying what we've learned. This understanding directly enhances our code quality, making it clearer, more reliable, and easier to maintain. And at the core of all this is effective programming, knowing how to choose and use the right structures for the right tasks. Overall, mastering these structures and practicing consistently are essential for boosting your programming skills and achieving better results in your projects.